Warning: this video contains super awesome content not suitable for people who don't enjoy super awesomeness. Viewer discretion advised.
Assalamualaikum and hi, my name is Akina AISHAH YEAP and I'm from KOLEJ MATRIKULASI JOHOR. I have the mood to watch TV.
Ethanol is not just any competitor, it is the better fuel. It has always been the better fuel.
Here's the thing about alcohol. Anyone can make it. I mean, making alcohol is mankind's second oldest profession.
Wait, we can make alcohol? The aim of the experiment is to create 300 ml of impure ethanol. The materials and apparatus that we need are Saccharomyces cerevisiae, yeast, sugar, tap water, distilled water, gloves, beaker, glass bottle, filter funnel, strainer, bowl, spoon, thermometer, safety goggles, cutter, and scissors. Let's begin! Sterilizing the apparatus. 100 Celsius of water is used to sterilize the apparatus to prevent foreign bacterial growth in the ethanol. The apparatus is let to dry in a closed environment. 100 ml of warm water is measured and put into a bowl filled with sugar. The solution is then stirred. The solution is stirred until all the sugar is dissolved. Your sugar solution will look like this. 10 grams of Saccharomyces cerevisiae is put into 40 Celsius of water. The Saccharomyces cerevisiae solution is then stirred until it becomes a homogeneous mixture. To check if your yeast is alive, sugar solution is then put into the homogeneous mixture. The solution is then stirred. Foams are being produced, which means the yeast is alive. The Saccharomyces cerevisiae solution is then put into a glass bottle using a filter funnel. 300 ml of sugar solution is then put into the glass bottle using the filter funnel. The solution is then stirred until it becomes a homogeneous mixture. A reminder, please make sure that all of the apparatus is sterilized. The glass bottle is now closed. The rubber band is tied around the glass bottle to ensure that no air will escape or enter the bottle. This is where fermentation process occurs. These are the equations for the fermentation process. Carbon dioxide from the Saccharomyces cerevisiae will enter the bubbler. The air bubbler acts as an airlock to allow carbon dioxide to exhale the glass bottle but preventing any form of gas entering it. All we have to do now is wait patiently. The water in the air bubble starts to change its color. No, this is not the end of the process.
One eternity later.
Bum. Now, the water in the air bubble becomes really cloudy. Time to filter the insolubles. The impure ethanol is filtered using a strainer. The impure ethanol is moved into the apparatus. Time for the purification process. Now we are going to turn impure ethanol into pure ethanol. The problem now is we don't have any suitable lab equipment for this process. The solution is we are going to use a DIY distiller. This is the distilling apparatus. The impure ethanol is heated up using a DIY Bunsen burner. The results are 3 ml of pure ethanol. The purification of ethanol may be varied as there is no suitable distilling apparatus. The precaution steps are: we can add molecular sieve into the impure ethanol before distillation to increase the absorption of water. That way we will have more pure ethanol after the purification. Now time to calculate the carbon dioxide from fermentation. So we have a basin full of water. This will replace the pneumatic trough. You will notice that there is no air bubble on top of the glass bottle. We are now collecting gas over water. The carbon dioxide gas is transferred through the tube into the glass bottle. The carbon dioxide gas bubbles to the top and it forces water out of the glass bottle. So here we are able to measure the volume of gas collected. The carbon dioxide gas collected is 40 milliliters. Now let's continue watching TV.
Profession. We have so many things we can use for making alcohol. We can grow things like beets. We can grow sweet sorghum, the agave plant, mesquite, buffalo gourds. Many of you have seen this plant flowering. This is a flower from cattails. These can generate 7 times as much alcohol as corn or prickly pear. So what is the best alcohol crop? It's the one that's best suited to your soil and climate where you are.
Time for explanation. I know explanation can be boring, but who knows? Maybe you will find it interesting. This process is called fermentation, and that's what we're going to focus on. Fermentation is a way to be able to handle the little to no oxygen issue. It allows glycolysis to happen, and for glycolysis to keep going, that means making ATP where there is no oxygen. And well, you won't be able to make as much ATP in this process as you would in aerobic cellular respiration. You can't be too picky when oxygen isn't around. Alcoholic fermentation is done by some type of yeast. So first, glycolysis happens, which yields 2 net ATP, 2 pyruvate, and 2 NADH. Now, we need this step to regenerate the NAD+, so we can keep doing glycolysis. The 2 pyruvate is used, which will alternately produce carbon dioxide and 2 ethanol. But the derivative of pyruvate shown here, L-acetaldehyde, can act as an electron acceptor in this process. So, the 2 NADH can be oxidized into 2 NAD+, so that glycolysis can start all over again. Since ethanol is a waste product in this process, this is why many yeasts are used to produce alcoholic products. Yeast can also do alcoholic fermentation in making bread, and the carbon dioxide produced is involved in helping the bread rise. The tiny amount of alcohol produced in the short fermenting time of bread will evaporate during the baking process. So overall, fermentation is a pretty remarkable process, although it does make us appreciate oxygen because despite how absolutely awesome fermentation may be, it can't just make as much ATP as aerobic cellular respiration. Wow, my week is spent well.